So in first year chemistry, we talked about a couple of different periodic trends. Now, there are obviously going to be exceptions to these rules, and we're actually going to be talking about them next year in AP Chemistry. But for the most part, as you move across the periodic table, the atomic radius decreases, ionization energy increases, and electronegativity increases. So just as a reminder, the atomic radius is simply the size of your atom. Okay? The ionization energy, remember, is the energy required to remove an electron, and electronegativity is an atom's attraction for electrons. So let's figure out why that trend exists. So as you move across the periodic table, atomic radius decreases. It decreases because as you move across the periodic table, the effective nuclear charge, or you can also say the number of protons, increases. So it's going to attract the electrons, causing the size to decrease. Okay? As you move across the periodic table, ionization energy increases. Why does it increase? Well, because since the effective nuclear charge increases and the atomic radius decreases, it's going to require more energy to remove the electron because the electron is closer to the nucleus. Okay, so as effective nuclear charge increases and the size of the atom decreases, it's going to require more energy. Electronegativity increases as well for pretty much the same reason. Since the effective nuclear charge increases and the atomic radius decreases, electrons are going to be more attracted to the nucleus. Okay, so those are key periodic trends that you need to remember because we're going to expand upon those quite a bit next semester. So it should be kind of second nature to be able to explain why the ionization energy increases as you move across the periodic table, why atomic radius decreases, etc. All right, as you move down the periodic table, the general trend is for atomic radius to increase, ionization energy to decrease, and electronegativity to decrease. And here's why. As you move down the periodic table, atomic radius increases. Why? Well, because you're increasing the number of principal energy levels. So with each principal energy level, your atomic radius gets larger and larger and larger. Your ionization energy decreases, and it decreases because the size of the atomic radius increases. So when your atomic radius increases in size, it requires less energy to remove the electron the further it is from the nucleus. Okay? And finally, electronegativity decreases again for the same reason. Since the size of the atom or the atomic radius is increasing, the electrons are going to be less attracted to the nucleus because they are farther from the nucleus. Okay, so review these trends, make sure you're comfortable with them because we're going to expand upon them throughout AP Chemistry.